Okay, so in this example, an airplane pilot is trying to drop a package off right outside the gates of a remote village without hitting the village itself. And so the question is, how far before you reach the village should the package be dropped? So if our village is located right here and our airplane is up here, then the package is going to follow a path that looks like this. It's going to be a parabola. And we want to land the package right there. So we want to know basically what we're looking for is the range. What is the range? So to do that, let's identify our information for the x dimension and y dimension separately. We know the airplane is 110 meters above the ground. We also know that the airplane is moving at 75 meters per second. So dx is what we're looking for. Vx is 75 meters per second. And t is an unknown quantity. In the y dimension, we have dy is equal to minus 110 meters. V initial y is equal to 0. V final y is an unknown quantity. The acceleration is equal to g. And t, once again, is an unknown quantity. So, like always, we're going to say for the x dimension that our equation is going to be dx equals vx times t. dx is what we're looking for, so our equation is already solved for what we want. And so vx is a known quantity, but t is unknown. So that means we're going to have to go to the y dimension in order to determine a value for t. We need to make a substitution here. So in the y dimension, we have to look at our equations, and we've got the position function, which could work quite nicely because we know the vertical displacement, the initial velocity is 0, and we can solve for t. And we would not really want to use the other two because v final is not a known quantity in this problem. So let's use the position function. So we get dy is equal to v initial y times t plus 1/2 ay t squared, and that goes to 0. So we get, solving for t, we get the square root of 2d over g. So what we're going to do is we're going to substitute that in for t, and we're going to get dx is equal to vx times the square root of 2d over g, 2dy over g. All right, so we have dx is equal to vx is 75 times the square root of 2 times 110, that should be negative, divided by minus 9.8. So once again, you can see how important it is that you acknowledge that the displacement of the package is in the downward direction, which makes it negative. So this negative is going to cancel with that negative. So dx is going to be equal to (75) times the square root of 2 times 110 divided by 9.8. That's 355 meters. So the airplane should release the package when it's 355 meters out in front of the village.